Today we're going to look at the law of signs, because chapter 7 is specifically looking at things that work, and obviously I'm seeing a typo right there. Ooh, left out my eye. How things work with oblique triangles. We're not, up here the title, Applications of Trigonometry and Vectors. We're not going to get into the vectors portion. I wish we would, but we just don't have enough time. But the applications of trigonometry, there are certain rules that are absolutely lovely. Law of sines and law of cosines are wonderful. So the nicest way to put it is as an analogy. If you think of quadratics, if you've got like x squared plus 5x plus 3, if you wanted to solve a quadratic, the fastest way to do it would be to try to factor it. That's the fast way. But if you can't factor, like this one that I just made up does not factor, then you know that you could take the quadratic formula and you could solve this thing. So the quadratic formula will work on everything, the quadratics that factor and the quadratics that do not. Well, in trig, you're going to have situations. Everything that you've worked on up till now was rules specifically for right triangles. So all the stuff that you've learned about sine being opposite over hypotenuse and tangent being opposite over adjacent, all of that is specifically for right triangles. Well, if you're in a different situation where you're talking about oblique triangles, which is something that is not a right triangle, then you need another rule. So just like the quadratic formula takes on all those things that don't factor, then the law of sines and the law of cosines, they take on all of those other situations as well. So the law of sines and the law of cosines, they work like the quadratic formula does. They will solve everything, even the right-angled ones. But if you're needing to make sure that you can solve it, the law of sines and law of cosines are the ways to go. Now, the law of sines, we're probably going to have 2 videos for it, because there's an easy way and then there's the not so easy way. Law of cosines is not nearly as tricky, but law of sines, we're going to have to work on things. So just as an overview, the first thing we're going to talk about is the nice case, where I give you 2 angles. Now keep in mind from geometry class, these are in order. So you could wrap around your triangle and you could tell me, all right, I've got a side, I have an angle, and I have an angle. Or I could give you a triangle and you could say, oh, I have an angle, I have a side, and I have an angle. So, and it's not necessarily going this way around it. You could have gone this way around. That's fine. But just know that 2 angles makes this very simple. This is the simplest form, makes it easy. Very straightforward, nothing weird if you have 2 angles given. Now case 2, the one that we'll catch in the next video, this is the case from geometry class where you really didn't do it, because quite honestly, if you turn that little thing around, we didn't write that word. It's what is called the ambiguous case. We'll get into that in the next video. So he's kind of naughty. And he leads into some questionable situations, which kind of ties in with his name. So let's do the easy case first, and then we'll get into case 2. So let's see how law of sines is set up. Law of sines is based on these 3 ratios. So you're obviously not going to use all 3 ratios at once. You're going to pick any 2 of them that you need at one time and use them. Basically, you set it up as a proportion. Now, some textbooks set them up that way, and then some textbooks will set them up in a reverse. It really makes no difference whatsoever which way you see it. Okay, so if you want your sines on top and your sides on the bottom, no biggie. Just keep in mind that capital letters, those are angles. Lowercase letters, those are sides. Big difference, okay? So here we go. Let's dive in. We're going to start simple, and then we'll slowly complicate things. Okay, very first thing, solve the triangle. Now remember, solve the triangle means find all the sides and all the angles. So you know off the bat, you're not done until you have listed all components. So go ahead and Put them out there. All right, we know angle A is 32 degrees. Angle B is 81.8 degrees. And then we know little a is 42.9. Now, I should have a units on that. Maybe it's inches, units, whatever, meters. Okay, we have to fill in the rest of it. Now, sometimes, like in textbooks, they'll save space, and this is all the information they'll give you. On ACTs, they like to draw the picture. So it's nice for you to be able to basically be familiar with both formats. Because if you come in here and you actually transfer this information to a triangle, remember the side is opposite the angle, so if angle A is here, side A is over here, directly opposite. That's the kicker right there. For you to do lost signs, think of it like that. You've got to have the angle and the side opposite. When you can do that little circle there, you've got a ratio. If you don't, then you've got to go fishing. Of course, finding the third angle is not a big deal. You just need to grab a calculator, and here we go, 180 minus 32 minus 81.8, and we get 66.2. Okay, now, let's go. We got to find out B and C. So our complete ratio is with A's. So I'm going to do A over sine A. And then let's look for little b first. Excuse me. Little b is going to be here. Now let's fill in all the things that I need. Little a was 42.9. And A is sine of 32.2. And then little b, I don't know, so I've got to leave him there. And then I've got sine of 81.8. There we go. Now, I've got to cross multiply. It's just a standard proportion here. Cross multiply your proportion. And then we're going to do 42.9 sine of 81.8 equals b times sine of 32.0. Now, you're looking for b. So you have to divide by sine of 32. Not just 32, but sine of 32. Okay? Now keep in mind on ACTs, if you were doing this on an ACT, you're supposed to be able to solve every problem on that ACT without a calculator. So they can't ask you to actually compute this unless they give you the decimal equivalencies. Normally this would be the way the answer would be written. So if you're used to writing it this way and solving it this way, then the ACT is not going to bother you at all. So the only thing we have to do is type this in our calculator. So just to keep it safe, I would type in 42.9 and then times sine of 81.8. I would hit the enter button because on these graphing calculators, the calculator automatically opens up parentheses and you just don't want to forget to close it, you know. So you get 42.4. I wouldn't worry about writing it down. Just go ahead and hit the division sign and then sine 32. But I would break it up in my calculator. Now notice, we have 3 digits, 3 digits, 3 digits, okay? All right. We're just going to get a little bit of the announcements here. So,
about to begin testing, and they're testing in 5-1, so students will let you know when to go to break, and we need to stay away from that area.
All right, we're going to get started with finding C.
Be careful and quiet around that area.
Yes, it's the end of the year, and we are trying to get testing done. That's one reason getting these videos completed is important so that we can do what we need to for class. Okay, so we have the same similar setup. So I'm copying this ratio. It is copied over here, but then I changed. Instead of having a ratio for B, I'm having a ratio for C. And so then we're going to go through and we're going to cross multiply. Now, the more you do this, the more comfortable you are, the less you may want to write. Okay? So you may not want to write all this business because you may get used to what's going to happen, when it's going to happen, how it's going to happen. And that's fine. That's up to you. That's a personal decision. Okay. 42 point, oops, I forgot my point. 42.9 times sine 66.2, hit enter, divided by sine 32. All right, I got 74.1. 74.1, I have solved my triangle. I have all three angles and I have all three sides. That concludes the law of sines. I did it. Now there's one thing that I should have done, and so let me just backtrack just a minute. In all honesty, I was trying to get through this really quickly. When you're doing the law of sines, technically speaking, you should use your angles, in order of size. So this one, angle A, we were given the side opposite it. But for B and C, technically speaking, we should have done C first. You should always do them in order of which one comes next in, I can't come up with the word, but it's basically in size. So the next largest one was 66.2. We should have done C next and then B. So if there was any variance or something, that takes care of it. So my bad on that. On the next time, we'll pay attention to the size of the angles. Okay. Now, you will be getting some problems where you have word problems. And this one, there's a river coming through here. There's a set thing over here. I do believe this is A. This is C, this is B. He comes through here and he says this angle right here is 112.9. This angle is 31.10. And little b, this side, is 347.6. Find the distance across the river. Well, the distance across the river is right here. That is little a, right? Now, if you look at that, remember what I showed you a while ago? You would have to draw this. Well, we don't have, well, we've got little a in this, so we can build that. We're good. Sine 31.10. We don't have another complete ratio, but you can get it. You've got to figure out what angle B is. So it's not real hard. Just do your 180, subtract out your 31.10, and subtract out your 112.9. So we're down to 36 degrees. So over here we're going to do little b, which was 347.6, over sine of, we found to be 36. Cross multiply. Sine 36, and then I'm going to have 347.6 sine 31.10. Now, if you'll divide both sides by sine 36, we should get this answer. So let's see here, 347.6 sine of 31.10, and then I'm going to divide that by sine of 36. That would be 305.5, and I do believe that's going to match what I need. Remember, it's kind of like parallel structure in an English class. Whatever is given in the angles, that's what you need to maintain if your answer is an angle. So like here where I wrote 36, I really needed to be a little bit more persistent because in the angles I have 4 significant digits. This needs to be 36.00. Okay, for the sides, parallel structure for significant digits. So I have 4 significant digits. I need 4 significant digits for my sides. But that's all it asked for. It didn't ask you to solve the triangle. That was all that we needed. Okay, now the only thing they can do to upgrade these problems is to include degrees, minutes, and seconds, but I don't think you're going to have any trouble with that. So y'all go play around with it and let me know if you have any trouble.